Let's move to the question. This is in 2019, paper 2, part B. Usually you will be getting a compulsory question combining the volume part as well as the logarithm part. Here's that question. Okay, let's read it. They say there's a hemisphere, right? Completely filled with water. Okay. Now that water is taken out and moved to a glass container in the shape of a prism, which means you're pouring that water to a prism. The cross-sectional area of that prism is given, right? Okay. Such they say there's no wastage of water. That is important. There's no water wastage. Then this water fills this glass container to a height of 10 centimeters. Show that the radius is equal to this much. Right. Uh, I'm gonna use a figure to indicate the details. Right. Here's the cross section. This part is 6. This part is 4. Now what is filled up to the height of 10 centimeters, right? Here's that water volume, right? Now this water was poured, that water volume was previously inside a hemisphere, right? Where the radius is r. This was completely filled. Here look at the formula. Volume of a hemisphere is given by 2 over 3 phi r to the index 3, right? So you can easily find the water volume here. That will be 2 over 3 phi r to the index 3. That is the volume of water. This is exactly here. What can you say about the volume of water here? How can you capture the volume of water here? You will find a uniform cross section. That is nothing but a right angle triangle, right? Right angle triangles are everywhere here. So how can you find the volume of water here? Cross sectional area times the length or the height, right? What can you say about the cross sectional area here? That is half into 4 into 6, right? Height is 10. Now that exact water volume is here, right? They say there's no wastage of water, so you can equate these two, right? So we can write volume of the hemisphere is exactly equal to the volume of the prism. This is 2 over 3 phi r to the index 3. Volume of this prism, water volume of this prism is given by half times 4 times 6 into 10, right? Now look here, the unknown term is r to the r, right? R is raised to 3. Let's try to simplify. I can simplify 2 with 4 as 2 here. Then I'm gonna isolate r to the index 3, right? Which means you need to multiply both ends by the reciprocal of the front coefficient here. The reciprocal of it is 3 over 2 5, right? Then multiply both ends by that fraction. This will be 2 into 6 into 10. This will be 3 over 2, 5. Right? 2 is cancelled. This will be 60 times 3 is 180. So the numerator will be 180, denominator will be 5. Right? Now check your answer. Right. 180 over 5 is here. Then how can you move from index 3 to index 1? Now, up to now the index is 3. You need to move to the index as 1. Then multiply the index by 103, right? Which means you need to take the cubic root. By taking cubic root. So this will be R. R equals 180 over 5. You can use the radical sign. Radical 3 is there, right? That's the answer they want. Now the basic part is done. Then they say by substituting phi as 3.14, we need to find the value of R. We need to find the numerical value. For that case, you need to use logarithms. Okay. Okay. Now this is the log part. Right. To find R, right, I'll use the original symbol 180 over 3.14. Somehow you need to take the division and you need to take the cubic root of that value. In this case, now look here. I'm about to teach you a simple thing. You need to turn each and every number to the scientific notation. Let's see. What is 1? 1 means 10 to the index 0. What is 10? That will be 10 to the index 1. What is 100? That will be 10 to the index 2. What is 1000? That will be 10 to the index 3. Right? Now look here. 3.14. 3.14 means somewhere here. Right? 180. 180 is somewhere here. Right? Then the index will be, here the index will be 10 to the index 0 point something. Right? Here the lowest index is 2, highest index is 3. Therefore, in between this range, each value can be represented as 10 to the index 2 point something. Right? Okay. I'm going to use that technique. Now I can write R is equal to, I'm going to replace 180. 180 is somewhere here, so that I can write it as 10 to the index 2 point something. Second one, I can write it as 10 to the index 0 point something. Is that clear? I hope it's clear. Now, we need to find the remaining digits, right? We need to find the remaining digits here. So let's use log tables. 180 means 18 0. This is not actually 18. This is 1.8, right? But it is printed as 18. Right? Second one, 3.14 means simply as appeared 31 is there under the fourth column. You need to grab that value. Right? Let's find those answers. 18 0 and 31 4. 18 means this value, right? 31 4, this value, right? 2553 with 4969, right? I'm gonna use it. 2554 4969. Make sure to take the cubic root of the entire fraction. Right. How to simplify this one? It is something like a to the index x over a to the index y times n, right? Which means first you may simplify these two. That will be x minus y. Then a. Then you can write it as a to the index n times x minus y. Right? I'm going to use that. Then find the difference of these two values, these two indices actually. 2554 minus 0.4969. Then take the cubic root. Right? What can you say about the difference? 2.2554 minus 0.4969. This will be 5. This will be 4 again. Then this will be 8. This will be 4 again. 5 is here. 1. 11 minus 4 is 7. This will be 1. Right? So the answer is R equals 10 to the index. The final index will be 1.7585. But don't forget, another 1/3 is there. Then you can write R equals, here you can multiply, right? Multiplying something by 103 means simply the division. Then divide this number by 3. Divide 1.7585 by 3, right? Let's divide 1. There's nothing, which means 0. Then for 17, that is 5. 5 times 3, 15, remaining 2. 25, that is 8. 24 is there, remaining 1. 18, that is 6. Exactly 18. You will find 1 here. Or by thinking about the next number, you can put 2, right? Now you need to find the location of this value. Remember, the main number is 0 point something. 0 point something. 10 to the index 0 point something. 10 to the index 0 point something means the final output will be between 1 and 10. Right. Let's find the location of 5862. Where's 5862? 5862 is not there. 55 is there. To obtain 62, 7 is remaining, right? Now 7 is here. Now grab those two places. This is 5. This is appeared as 38, but the real value is 3.8, right? Okay. So the answer for 0.5862 is nothing but this is 3.8, then 5, then 6, right? So the answer will be 3.856 in centimeters. Clear? Right. Okay, let's move to the next one. Now I have given you the formulae of the volume of a sphere as well as the volume of a cylinder in terms of R and H. They say there's a cylinder where the radius is R and the height is 12, right? You need to think about the water volume. Yes, the water in this container is just enough to completely fill 16 hemispherical containers. What do you mean by that? Initially, there's a cylindrical vessel, right? There's water up to the height of 10 centimeters. I'm sorry, up to the height of 12 centimeters, where the base radius is R. Now, that water volume is used to fill hemispherical containers, which means hemispheres. What's the quantity here? 16 hemispheres are there, right? Where the base radius is 4. Simply you can say volume in this container is equal to the volume of 16 such hemispheres, right? Clear? So I'm gonna write this one first. I'm gonna write this one first because the unknown term is here, right? Volume of the cylindrical container, volume of this water is equal to volume of a hemisphere times 16, right? Is that clear? They say there's no wastage. They say the water in this container is just enough to completely fill. We need to assume that there's no wastage, right? For your concern, I'll write it here. Assuming that there's no water wastage of water. Right. Think about this one. Let's write phi, radius is r to the index 2 times, what's the height? Height is 12. Think about the volume of a hemisphere. That is nothing but 2 over 3 times phi r to the index 3. 2 over 3, phi. What's the radius here? Radius is r. Radius is 4. R to the index 3 times 16, right? Okay. It's about to find r. You need to isolate r. Before finding r, you need to isolate r to the index 2, which means you need to remove 5 and 12, right? So I'll combine them together. This will be equal to, I will write this one, 2, 5, right? R to the index 3 times 16 over 3, right? Okay. Now I'm gonna remove this part, which means I need to multiply both ends by 1 over 12 phi. Just take the reciprocal of this, right? So r to the index 2 will be equal to 2 5, right? I'm gonna elaborate this one. 4 times 4 squared, right? 16, just to cancel numbers. This will be 1 over 12 times 5. Now you can easily cancel 2 5 and 12 5 with the factor 6. Again you can cancel, this is 2 times 3, this is 2 times 2. R squared is equal to what? 16 is there, another 16 is there, finally 16 square is there, right? Another factor 2 is there here, then 3 squared is there, right? Okay, right. How can you reduce the index from 2 to 1? Just take the square root, right? By taking square root on both sides, you will get the answer for r. This will be, make sure to put plus or minus. 2 over 3 square, right? Now you can separately put the square root sign. This step is not required. If you are okay with the simplifications, you can directly get the answer, right? This will be now this is something like a squared to the index half, right? Which means you can multiply these two. Finally the answer will be a, right? You can cancel squared with the root. There's no cancellation, so the answer would be 16 times root 2 over perfect 3. Now you can filter, as r is a positive value. R means a radius, right? Radius can't be negative. Therefore, you may write as r is positive always. Therefore, r is equal to 16 times root 2 over perfect 3. That's the answer. Look, how simple is that? Right? Okay. The first part is over. There's a logarithmic part, part B. A equals 65.2. Now I'm going to use logarithms. (65.2) times 0.722 over 3.06. Right. Let's consider all the numbers inside. 0.722, 65.2, 3.06. Right. 10 to the index 1, 10. I'll write it again. 10 to the index 2, which means 100. Right. Now, look at the interior value. 65.2. 65.2 is what? Where? It is somewhere here, right? 65.2 is here. What can you say about 0.722? Let me write 10 to the index 0. That will be 1, right? 0.722 means somewhere here, right? There's no a proper way to write. Then how can we find the exact log value? Then you need to use scientific notation. Actually, in all the cases, generally in logarithms, you can use scientific notation for any number, right? But to reduce the time, we can easily grab this answer as what? 65.2 means somewhere here, which means you can write it as 10 to the index 1 point something. Clear? Obviously 3.06 is here, it's fine. This is what? 10 to the index 0 point something, right? Now there's a problem with 0.722. I'm gonna write it. Okay, let's write A. This is 65.2 with a new version. Index is halved. This can be written as 7.22 times 10 to the index negative 1. This part is okay. This part is okay. Now this is okay too. Look here, 7.22, a number less than 10 but greater than 1. 7.22 is here. Again, that can be turned as 10 to the index 0 point something, right? So the problem is solved. Right. This is exactly 65 means somewhere here. 65.2 is somewhere here, which means the number is 10 to the index 1 point something. 10 to the index 1 point something. Make sure to take the half index. 7.22 means somewhere here. That is 10 to the index 0 point something into 10 to the index 1. 3.06 is somewhere here, which means that will be 10 to the index 0 point something. Right? Okay. Now let's find out these digits. 65.2, 7.22 and 3.06. Let's find out what is 65.2. 65.2. Sixty-five is there, 2 is there, right? The digits are 8142. 8142. Second one, 7.22. 7.22. 7.22 means 7.2 is there. 7.22. 8585 is the answer. 8585 is the answer. This is what? 3.06. 3.06. Right. So 3.06. 3.0 is here. 6 is here. Which means the answer is 4857. 4857. 4857. Right. Look at the bases. Base 10 is there, base 10 is there, base 10 is there, base 10 is there. Everywhere you will find base 10. Then you can use the laws of indices. This is the product of 1.8142 times half, which means you need to divide that value by 2, right? 1.8142 over 2. 0.8585 times 10 to the index negative 1 over 0.4857. Right. Let's simplify. Let's find the answer here. That will be 0.9071. This will be 0.8585. 10 to the index negative 1 is here. 0.4857 is here. Right. You can combine these three together and you can take the difference. Right? When a to the index over a to the index y can be written as a to the index x minus y. Right? I'm gonna combine these three indices together. You can add them and check the difference from 0.4857. Right. 9071 8585 minus 0.4857. Again, negative 1 is there, right? Let's simplify these three first. 0.9071, 0.8585. I'm gonna add. This is 6. This is 15, remaining 1. This is 6. This is 17, remaining 1. Right? .7656. After adding these two, the answer will be 1.7656. What can you say about these two? That will be negative 1.4857, right? So I can do the subtraction. 1.4857. This will be 9. This will be 4. Then 14 minus 5. That will be again 9. Here 5. 7 is there. 6. 6 minus 4 is 2. This is 0. Right? The answer will be 0.2799. Now look at the answer. The front value or the characteristic is 0 point something. 10 to the index 0 point something means the result will be in between 1 and 10. Right? Let's find the location of these 4 digits. 2799. 2799. Where are you, 2799? Where are you, buddy? 2799. 2799. 2788 is there. 11 remaining. 11 is here. The column 5 is there. Main column 0. Under the category 1.9. This is not 19. This is printed as 19, but you need to remember this is exactly 1.9. Right? So 10 to the index 0.2799 is equal to, write the first one, 1.9, then 0, then 5. That's the answer. .905, right? Did they say something? To the nearest second decimal place. Alright. Nearest second decimal place, which means 1.91, right? No units are there. Yes. That's it. Right.